My name is Rohit Srivastava. I'm an individual security researcher from India. Been doing offensive and defensive security for both large enterprises, government, and across multiple countries. And as a volunteering activity, I help first in a lot of activities, and this is one of the stuff where I'm here. We have.
Hi, I'm Adli Wahid, currently working as a security specialist at Asia Pacific Network Information Center, one of the regional internet registry. I've done some work in various certs before. I used to work for the Malaysia cert, and then I went to work for a cert for an international bank. I've been doing work for the community for quite a while now, and happy to interact with you in this training.
Okay, Adli, so let's start onto the security topic and the slide, the boot camps. So there are a few basic questions which comes about security, and everybody thinks about it or they have heard about it in news in different places. So first question, have you ever been affected by a virus?
I haven't really been infected by a virus, but I've come across many situations where people, devices, whether it is a phone or a computer or a server, has been infected by a malicious software. And it's very interesting to see what happens when a system is infected by a piece of malware. A piece of malware could disrupt the work for an individual or an organization. But I think more and more now we are seeing malware that actually try to ask for ransom. So this puts organization in a very interesting place. So yes, I mean, virus or malware infection, it's a common thing in the world of computer security.
So the next question is connected to the first one. You're not infected by a virus, but your life has been affected by a virus?
Yeah, of course. I think people around me, people who I've worked for, have experienced some sort of a malware infection, and therefore putting myself in a position of someone who runs a cert, for example, we have to provide not only solutions to remove the malware from an infected device, but also to think about how to prevent this malware from infecting other computers on the network. And also trying to understand what is the root cause of the infection to begin with. I think this is quite interesting because then it brings upon many other issues, either in terms of how you do security overall, in terms of applying defenses to your system, but also having a policy in place, so things like backups and things like that, which I'm sure we will go more in our training today.
Yep.
Yeah. So I think one of the things that come across when we discuss computer security is the usage of passwords. I think more and more now, there have been encouragement that we don't just stick to password and start to use something like two-factor authentication. What do you think about two-factor authentication, Rohit?
So password is one of the things which is the most weakest point a human being uses for the information security, so to say. They think that it's secure, and then we have been hearing about a lot of breaches and passwords getting leaked and people reusing their passwords at one place and another, leaking the password and one breach, the same password used on another site, on another computer, and then similarly the attackers using that to infect, that has been increasing. So that's where the multi-factor authentication actually came into picture, where people said, okay, let me authenticate by something which I know, which is my username and a password, and something which I have, which could be a hardware with me, or which could be a cell phone with me having some information, or a cell number with me, which can get an SMS. So variety of stuff where we have the second factor of authentication, something which is I have. There's a third part of authentication as well in the multi-factor, which is the something I am, like my biometric, my fingerprints, my iris, my voice samples. There are a lot of other behavioral aspects as well coming onto the multi-factor. But that's something actually really, really important when it comes to authenticate, because that's the way a human start interacting with the computer in a secure manner. Have you been using two-factor authentication? I'm sure.
Yeah, quite a bit. I think for all of my online accounts now, be it Facebook or Gmail or Dropbox, I think I have enabled them in the last couple of years. And the good news is that all of the services now have them enabled. So I think if you haven't done so, maybe it's a good time to actually check out all these features from the accounts that you have online and enable them as soon as you can.
And the best part is it's free.
It is free, yeah.
No one is charging an extra penny to make your account even more secure using a two-factor authentication.
Yeah.
Okay, so next comes into picture is keeping your systems up to date and patched. So patching is something which everybody has been talking about as a very, very difficult thing or very mundane activity they don't want to. But if you have to put a value on that, why it is so important?
Yeah, so I think one thing that is quite common within this computer security industry is the notion of system being compromised or system being, or in simple words, maybe system being hacked by another person or another individual. And we see that one of the common reasons for this is due to vulnerable or weak software that has holes or weakness, which later on allow someone to exploit the vulnerability and gain access to that particular system. So this is where I think the understanding that not all systems are secure all the time comes into place, and therefore when you look at system, what you can see internally is a bunch of software that makes up a system. And from time to time, makers of the software or the system do announce to the users that, hey, we have a weakness in our software and we have issued a patch for it. And this is where you can then download and apply the patches. And one of the reasons of doing so is to make sure that the system do not contain holes or backdoors or avenues for people to exploit and later on gain access to the system. What's interesting about this is that sometimes when we use a phone or a computer is that we don't really understand what goes inside those devices. So there might be software that you're not even sure that it's there. And it's not just a software that you use on a day-to-day basis like Microsoft Word or Internet Explorer or Firefox, but it also software that you don't really see but are critical to the operations of the system. So for example, the operating systems.
Right. Something like the most popular ransomware which was there a few years ago was WannaCry and NotPetya kind of a stuff.
Yeah.
Where the whole problem was systems not being patched in the right moment, right?
Right, yeah. So I think when it comes to patching, many organizations still have difficulties in managing this as a whole because you're not talking about just one computer or one system, but also many systems that does different things. So it could be laptops, it could be computers, servers, it could be even printers that you have in your organization. And as I mentioned earlier, or I alluded earlier, it is not just things that you see or use on a day-to-day basis, but it could be in the form of things like firmware or system-level software. So I think the bottom line is you have to understand what you have in place to begin with before you can really understand the amount of work that needs to be done in terms of making sure that you are always up to date. So this is keeping track of things, keeping track of where things are, keeping track of the status of things, and also keeping track of the vendors who are producing the software, whether or not they have issued patches lately for you to download and apply.
So that's a very interesting point, keeping up to date. And that's for both, right? The computer systems and the human mind itself. You have to be updated about what's happening in the industry and what are the latest attacks being coming on, and then how you can patch your knowledge yourself and then patch your systems as well to make things are in a secure and safe manner.
Yeah, absolutely. So I think in this space, we can now see that security is not static, which means that maybe you learn something today, but tomorrow, the environment has changed, and therefore, as practitioner, as the one who is managing security for organizations or the one who is managing security within a particular ecosystem, you have to keep yourself up to date. And I think by being part of the community like FIRST, or by attending events or conferences, it's one of the ways to sort of learn what's out there,
right,
and what has been happening, and maybe take some of the best practices that people do on a day-to-day basis to maintain the security of their infrastructure or environment.
Okay, so you said you are working in an organization called as AppNic.
Yeah.
And from what I know, or let me tell people as well, that you manage IP addresses of the whole Asia Pacific region. In a very, very nutshell, that's the whole profile. So IP addresses are something which human beings are not very, very good with remembering and managing. So if we can start talking about to people that, okay, what is this IP address? Why is it there? And why is it so important to manage and then use in the whole information security?
Yeah, so let me track back a bit when we want to talk about IP addresses. So yes, I work for an organization called APNIC. So we manage the delegation of IP addresses to the whole Asia-Pacific region. And in fact, there are 5 organizations like us throughout the world. Now, when it comes to cybersecurity, IP addresses are very important because they are sort of like an identifier of a device or a node that are connected to the internet, right? When we handle cybersecurity incidents, oftentimes we want to understand where the attacks are coming from or where the attacks are going to. And in the cyber world, IP addresses is one of the identifier that we use to identify an object that are connected to the internet. So that's one aspect of it. But the big picture is when you want to connect to the internet, you will need an IP address. And therefore, organization like us delegates IP addresses to network operators or network providers. And they will get a set of IP addresses which then get delegated to end users. And I think this is very important because there are a couple of things that you have to understand within the IP address space. One is that it is part of the network protocol or internet protocol. And therefore, IP addresses get assigned to systems. And there are ways to assign IP addresses to multiple systems. Number 2, IP addresses tend to be unique, right? So that the traffic or the packets arrives at the destination. And then another notion that is quite important with this is that IP addresses do have a specific format to it, right? And these days we are talking about, maybe you have heard of IPv6 and IPv4. What it is basically the underlying protocol is pretty much, addressing the need to connect devices to the internet, but the formatting or the protocol and how this works could be slightly different. The other aspect about IP addresses when it comes to those who are responding a security incident, right, is that IP addresses are important for doing, for understanding the root cause or the origin of where, for example, attacks are coming from or problems are coming from. And that's why in many of the CERT or security teams interaction, you see, they asking one another for indicators, if you're talking about a particular attack, do you have more details or more information? Things like IP addresses, or maybe later on we'll talk about domain names and things like that. So understanding internet addresses or IP addresses is important, not only because this allows the internet to work together, but also when it comes to doing CERT work or incident response work, it's one of the items that is on the menu when we are doing analysis or when we're doing investigation.
So that makes it even interesting. The moment I pull out my phone, connect to a network, and start browsing maybe any social media app or book a cab on it, technically I'm on the same one of the IP addresses which are provided by one of the organizations, which is controlled and managed by one of the organizations like yours. Every device which is talking on internet has an IP address, right?
Correct.
That becomes the identifier of it, and that's where the whole communication starts. The fun part comes into picture when how do these IP addresses talk to each other, and what is the way from one place the data or communication goes up to the other end of the network. So if you remember the old telephone systems where you used to call up to the switch or the exchange and ask for a number to be dialed, and the person would connect you physically or manually to another phone line, and then you actually end up talking to them. So now that thing has been moved over to internet, and now we have IP addresses talking to another IP addresses with a set of protocols, and then getting connected to each other. So if we can talk more about that, that will be easier for the people to understand how this whole communication works.
Yeah, so IP address by itself doesn't do much, right? So I think for communication to happen on the internet, there's something that is more interesting, and this is called routing. And this is where I think the getting packets or information from point A to point B. And routing in itself, it's very amazing, quite amazing. I would suggest that our audience take some time to look deeper into this, outside the realm of this course, because what makes the internet works and talks to one another. So a user in Afghanistan, for example, or in Zimbabwe, right, is now able to access servers that is located in London or Amsterdam, right? And this happens through a concept, this concept of routing. Right? And routing happens because network operators, people who receive a significant number of IP addresses and provide the internet connectivity to end users are now allowing or advertising their routes, right, to others on the internet. And the beauty of this whole thing is that the sharing happens on sort of voluntary basis, right? So where one organization now announces to the neighbor, right, that hey, if you want to reach me, please send it to this location, right? And what's interesting about routing itself is that there are nodes on the internet called routers, right? So of course, and what it does basically is route packets that contains information from application from one location to another, right? And again, what I like about this whole picture is that to get from one location to another, your packets or your information might be routed through different internet service providers.
Different countries,
different countries and different location. And it eventually gets there, right?
Within a fraction of a second?
Yeah, within a fraction of a second. I mean, this is something that maybe many, many years ago was very unthinkable, right? But because of this collaboration that takes place within the network operators within the providers world, we are able to basically connect devices in different regions, in different places, and they work to a certain extent. Of course, there are algorithms and a lot of technicalities behind the scene, but there's always some elements of redundancy. There's always elements of stability to make sure that this works all the time. And there's also an element of security as well, because we want to make sure that the packets that is being sent is sent to the right person or to the right places. And also, maybe those packets will contain some sensitive information, and therefore, what security mechanisms can you put in place to make sure that information that is traveling from one networks to another, is safe and secure within intent and purpose of the original sender.
That brings me to an interesting thought itself. Mm-hmm. What are we at a first? Aren't we a router of helping one country member to another country member to talk to each other and get the problem solved or get the communication happening between each other? So are we not working like a physical routers in this real world? Well,
in some sense, maybe you can say that, right? But that's basically, just extrapolation of our function. But you can say that. I think one of the things that first provide is a platform for certs to come together and sort of announce to the world that, hey, I'm a cert.
And here I am. And if you need to contact, all you have to do is...
Correct. If you need
very similar to a router's activity.
Right. So if you need to relay messages, to constituents in my economy, then you can relay it to me, and I will make sure that I'll make the introduction. So something like that.
Great. So when I get connected to internet, I have an IP address. That IP address I get from my company or my telecom provider. My telecom provider has pool of different IP addresses. So how do I know, or how do I manage that, okay, from range X to Y is with me, from range M to N is with me, and there's a mixture of that and a combination of that. So isn't it very clumsy and difficult to understand? Or is there an easy way of making it understand?
Oh, definitely. So there's one thing that I haven't discussed about when it comes to this IP address or how the internet works or talks to one another. So there's also this concept of autonomous system. In brief, what autonomous system is that a network with the same routing policy as we see it. You can look at it from a different angle, however. So for example, if I give a network block to a network operator, so let's say, ISPX, then ISPX will also get an identifier, right? Another identifier, which is called an AS number, autonomous system number, right? So these are, a number assigned to a network provider. And what it does in essence is that this identifier can then be used to say that if you need to send packets to a particular network block, let's say 10.0.0.0 to 10.0.2.0, right? Then it belongs to this particular AS number. And this makes routing and routing announcement easy to be done, right? So that you can then associate a network block and an AS number. And of course, an AS number belongs to a network provider, right? So things that you see on the internet when it comes to routing right, where we have routing tables, when we have route announcements, they all use AS numbers. Right?
Like for example, United Nations themselves have a AS number called as AS22723. So that's the whole identifier for United Nations to have a pool of net blocks, so to say.
Correct, correct. Yeah, and as you can see also that when you have, when network operators announce their routes, or when network operators need to make routing decisions, so that, given a packet with a particular destination, then they can look it up in the routing table, which says that, okay, if I need to send information to this, to go to this network, I will send it to this router, or to this AS number. Or if I want to send a particular packet to another location, then I can send it to another AS number, right? So this information is used hand to hand, right? So again, I think what's important to really understand is that, number one, is that there are identifiers related to things we see on the network. These are IP addresses, these are AS numbers. And this information can then be used to identify the source and destination of things. And AS number also will then allude us to who actually is responsible for the network itself, in terms of if you need to do some troubleshooting, right? Sometimes you need to debug the network to see whether the packets are actually going to the right destination or not. If we know what the AS number is, then we can say that, hey, I need to contact this organization so that they can do something about a problem. Right? Similarly, when you have a security incident or a security problem, this could be one way to identify who I should contact or I could communicate with.
The human being behind those set of computers.
Yeah. So if I know that, hey, there is a bunch of servers with a particular IP address, right? And then we can look up the AS number. Then we can know, by searching the WHOIS database, for example, who is responsible to handle the technicalities or the security incident. So I can reach out to a human being, as you said, to be able to tackle the problem itself.
Love the way this whole AS number, IP address, the topology, the interconnectivity has come since 1969, when DARPA actually created a rough diagram on the pen and paper to realize, oh, we will be connecting 3 or 4 set of systems together, from where now we have IPv6, which is connecting almost everything in this world onto the network, may it be a phone, a watch, a refrigerator, even a toilet seat. Now everything is getting connected to internet, and that's how we have expanded from a dream of DARPA getting things connected from 4 systems to millions and millions of systems. Now, something very important to understand here. You and me both are talking in English. If I start talking in my native language, will you understand it?
Probably not.
Then why do we decided that, okay, we will talk in English here? So that brings us to a basic building block of internet called as a protocol, a rule, a method of talking to each other. So like in human communication, we use language as one of the protocol. Plus the respect which we give to each other, the way of salutation to each other, all of that creates a part of a protocol. So now when it comes to the computer world, yes, there is a typical way in which a rule, a set of formulas defined in which 2 computers talk to each other. So if you can talk about quickly some of the protocols which is commonly used, and why is it different, or why not just one simple language for everyone to talk?
Yeah, so I think this is also where the internet creates this understanding, right, that for a device or an application even to talk to one another, then they have to use a set of protocol, right? A set of standards of communicating, so that, as you said, we know what to expect, right? And we know how to request for things from one another, and so on and so forth. So traditionally, when the internet is being invented, of course, there are mechanisms for 2 nodes or 2 services to be able to talk to one another. There are some fundamental protocols for transporting packet from one location to another. And this is in the form of the TCP, UDP, ICMP, and whatnot. But I would suggest that it has gone more complex than that now, right? Especially now with applications, where applications will want or need to talk to one another. For example, if you have a web browser that wants to talk or request something from a web server, then they will talk in a protocol that is understood by those 2 applications, which is called HTTP, right? I think what practitioners or people who are working in this field needs to understand is that sometimes when we deal with a particular security incident, without understanding how the protocol works, it's hard to really troubleshoot, right? Because we will not be able to understand what was intended to begin with, right? And second of all, what takes place when two devices or two applications are talking to one another. And this is where understanding the protocols behind the communication is very important and very critical, right? I'm sure you yourself have seen, the applicability of protocols in doing cybersecurity incident response or forensics work, right? Maybe you can talk a little bit about that.
So I love the way it all started, where initially it was just, few things were connecting, and we were not really worried on, things have to be secure. And slowly with evolution of the whole technology, whole IP addressing, whole networking, whole internet itself, the problem of security started slowly coming into the whole system. And remember, at one place we are talking about, we are dealing with systems which are not meant to be secure. Or we never thought of security at that point of time. Where in today's case, where we are really, really scared of any security attack or any misconfiguration there. So that way, it all comes into picture that security kept getting involved or evolved along with the development of the whole system. So you spoke about HTTP, and then later on when people realized that, that security is not sufficient, then HTTPS came into picture. So the whole browser talking to a web server language got a layer of security on top of it, and we started talking securely. But when it comes to the whole process, even in the configuration of a network device, or when it comes to any kind of a traffic allow or deny or stuff, computer understands just one very, very simple language. Source IP, source port, destination IP, destination port, and do what? Allow or deny. So where is my home? Which is the door? Is it a door or a window? Where is your home? If I have to come to you, do I come to the front door or the back door? So 2 homes, 2 doors, and then what has to be done? Do I allow it or do I deny? So that's where the whole basic of firewalling came into picture when we call a firewall. A firewall is basically a system which has just one simple rule. Based on the source IP and the source port, a traffic going to a destination IP and destination port, simply allow or deny it. That's where the basic or the initial core of security started with the whole protocol and IP addresses and stuff. But then that's how we started building up more protocols, more languages, and make it easier. Plus, the best part which was done is dividing different functionality into a different protocol. Like we spoke about web server talking to a web browser on HTTPS and now HTTPS. Similarly, every other group of applications, so to say, works on a different protocol. Like the most common one would be emailing. So email has a variety of protocols where email sending is a part of one protocol, email receiving is a part of another protocol. So email sending, when it goes, people call it as SMTP, and then layer of security added on top of that called as SMTPS. So that's how the simple mail transfer protocol got converted into simple mail transfer protocol, which is secure. When you get email, again, now they have 2 different processes. You can get it, keep the mail on the server and give a copy to me, versus the moment mail comes, download all the mail and give it to me. So there are all different use cases, and that's how different protocols evolved. So when initially it was like, the moment the mail comes, copy the mail, give it to me, and then I don't care if it is there on the server or not. That's where the post office protocol or POP came into picture. But then with more and more reliable internet connectivity and good service providers, people started, can I keep a copy of the mail on the server? And that's where the IMAP internet messaging protocol came into picture, where you just download a copy of the email, keep it on the server. With all of this happening, the attack scenarios also started increasing that, can I send a malicious traffic on your SMTP port or your POP port or IMAP port and cause a problem in any way? It could be an authentication issue, it could be a crashing of the server issue. So different protocols started facing different kind of problem. When you come to the security, we still depend on 3 basic things: the confidentiality of the data, the integrity of the data, and availability of the data. Confidentiality, when I'm saying something to you, it is between you and me. nobody else nobody else looks into it and realizes that what I'm talking to you. When it comes to integrity, when I say something to you, what you receive is exactly the same thing. Plus the third thing, the availability. I am in a position to talk to you and you are in a position to listen to me. That availability of the part comes into the part of the security. So we call it as the CIA triad in our paradigm in the whole security world. And believe me, everybody in the security world is fighting to make sure that these three things are intact. Plus, now when we move forward, Adley, you spoke about a thing called as compromise or indicator of compromise. That's where we spoke about, okay, internet IP address is something where you pass on to me that, okay, here's a list of IP addresses which are malicious in nature, which are doing wrong stuff. You may want to protect yourself from that. But that's so easy when a computer talks to a computer. That's not very easy when a human being talks to a human being. Yeah. So it would be a good idea to, at this point of time, to touch upon the very interesting concept called as domain name system or DNS system, and how it became easier for people to understand and people to interact with internet.
Yeah, absolutely. So earlier on, I mentioned about internet addresses or IP addresses, internet protocol addresses, and these are numerical representation that we use to identify computers or devices that are connected on the internet. Obviously, you know, the numbering system that I use are not easy to remember, right? I'm sure some of you may remember what the IP addresses assigned to certain servers, but not all of it, right? And therefore, addressing or accessing or even remembering some of these IP addresses becomes a challenge. And this is why another protocol was introduced, which is called the DNS, or the domain name system, which then helped translate IP addresses to domain names, or domain names to IP addresses. So instead of having to remember a number, right, we remember a name, right? So adley.com is a lot easier to remember than, you know, a bunch of IP addresses.
Do you remember the IP address behind your site?
I don't actually. So yes, that's the whole point. And it helps to then identify services that are connected to on the internet in a lot easier manner. However, when we use this system, then it means that we are also introducing some additional services on the internet, which does the translation, which does the addressing, having like a list of domain names and IP addresses. So we have a set of registries, and also what it means is that for those who are doing work on the internet, is that now we are talking to another stakeholder, which is the domain name registry. People who where you can go and get domain names, and they will register it for you and keep a record of that on your behalf. Right? So we have another set of players in this particular field. Now, how this works in the world of computer security is that nowadays, when we are looking at attacks that happens on the internet or security compromises and whatnot, there are elements of domain names that you have to handle. So either a bad person registered the domain name, or a domain name was part of a larger cybersecurity attack. Right? And therefore, it makes things a bit more interesting because sometimes that domain name may be pointing to multiple IP addresses. So these are probably the things that we will see later on in the course. But I think it's very important to understand that when you look at cyber, or when you look at the internet, then DNS is actually the piece that sort of glue everything together, right? And it is also now becoming a system of critical importance, that when a server that is providing DNS service goes down, right, then a lot of the applications that we use on the internet, a lot of the things that needs to communicate on the internet will not be able to function anymore because they are not able to do the name translation and so on and so forth. And we have seen some examples in the past where attackers do target name servers as part of a larger attack on the internet.
That's very interesting, the way whole internet is connected, and DNS is helping human beings to A, remember, and B, configure the stuff. But one thing which was a very interesting problem out there when we connected everything on internet is like, when my communication to you is going via 5, 6, 10 different nodes in between or routers in between. That would become so easy for anyone to actually look at the traffic between us, understand it, and that's where the whole confidentiality part of it could be lost. So that was one of the initial problem of networking. And now it has become so much dependent that everybody is today using computer in one way or the another, talking to one server or another. And that's where the secure communication, as we say, has become very vital and very important into picture. So would you like to put some thoughts on, or maybe the easiest way people can actually start understanding this concept?
Yeah, so I think as we mentioned earlier that the internet is a combination of networks working, volunteering together with one another. And as a result of that, when you are sending packets or information from one location to the destination, then that packet or that information traverses through many networks, some of which are not your own network. And therefore, there are possibilities of that information that is traveling within those packets can be seen by those who are operating the network, right? So we spoke earlier about protocols. There are protocols that has no security by default, which means that packets that are being shared from one application to the server are being transferred in plain text, right? So which means that, for example, if you are sending a bunch of passwords or confidential information, then there are possibilities of those information being snooped or being observed by those who are managing or processing the packets or the network. And this is where I think one of the security solutions that we hear a lot is in the form of VPN or virtual private network. And the thing that you have to see here is that not just creating a private tunnel end-to-end between the location and the destination, but also applying some element of encryption, which means that packets within the transaction are now being encrypted. And those packets can only be opened or be read by the intended recipient, right? So if I'm sending some traffic from my client, my web browser, to a server in my own organization, right? While it is traveling on the public internet, right? While it is traveling through networks that is owned or operated by other people, I can have an assurance that information that is contained within those transactions can only be received and be processed by the trusted endpoints. So while it is traveling throughout the internet, no one else can see it. So I have the assurance, or I have the capability to ensure that confidentiality, which is part of the CIA, as we mentioned earlier, the confidentiality of those information is now being protected. So that's one example of a security control that we can use to ensure confidentiality when using using the public networks such as the internet.
So one of the important aspects is now interconnection of multiple computers, and then using the secure protocol. I can use HTTPS between every web server traffic happening between two of my offices, and then it will go on a secure tunnel. But isn't that too difficult to actually create public access between two things using the same public internet which everybody else is using to upload their photographs on Facebook and have a chat on a messenger application and running my whole company data as well? So that's where the whole VPN comes into picture, that, okay, can I create a invisible secure tunnel between these two offices, that even if an application want to talk in plain text, open protocol between one network to another, I'm still preventing eavesdropping on that. I'm still maintaining the confidentiality of the data, that, okay, even though it is on a plain text, even though it is going via a public network, there is a tunnel created. And that's why it's very, very commonly known in this industry as tunnel. Oh, can I have a VPN tunnel between these two things? So that's where the VPN tunnel comes into picture, which prevents others to look at your data. But I'm sure there's a lot other ways by which the whole attack comes into picture. VPN secure protocols are just different steps which we take to secure our environment.
So I hope you have gained some understanding on why it is important to understand the fundamental of internet working when it comes to computer security, because in a lot of occasions we study or look into attacks that takes place on the internet, and therefore it's very, very important or very critical to understand, you know, the background of how things work, you know, the routing, the internet addressing, the IP addresses.
The domain name system, how it makes it easier for people to connect and interact with each other.
Correct, the protocols, and also from there then extrapolate some of the key ideas behind how we do mitigations, how we secure communications, how we make sure that only certain packets can access our networks, how we also look at the dependencies issues, not only between systems that provides information like DNS and services that are provided by other services like email and whatnot, but also to understand who are the players behind, you know, providing things like IP addresses or AS numbers or domain names, right? Who is responsible for, you know, making sure that the routing information is up to date and accurate and things like that. So it gives you a whole different perspective on, one, how the internet works, number two, who is behind the internet, and number three, the technology that is behind the internet. So if you are in this space, then, you know, you have to be very, not only literate, but also, you know, you must also be open to understand some of the technologies or advancement that takes place into this domain. And of course, what we have covered here is just, you know, very, very tip of the iceberg, I would say. There are definitely more to it, but I hope it will give you some appreciation on why it is very important to understand the fundamentals of networking when it comes to doing work in cybersecurity.